All right, this is my geometry class. This is my 6th hour. These people are geometry. They are going to try to finish the review for the exam. So we finish off on number 7, I believe. Okay, so since we finished on number 7, I'm going to go through and start there. Yeah, I'm going to start there. So if you guys have your vocabulary book, that's going to be helpful also. So, and if you have not been filling in your vocabulary book, we're going to have some issues with that. But I'm going to give you guys time and tell you what needs to be in it as we're going over this.
What if you don't have one?
Then you need to ask really nicely towards the end of class and see if we can get you one. Yeah. Okay, so you guys made a little thing like this with circles. I gave you this packet. Yeah, you guys actually had it.
Can I see yours? To make sure what it looks like.
It's going to look something like this, but it has circles on the front. I don't know. I had it on the desk and I let someone borrow it because they're all like, "Hey, I need the notes." So I'm like, "Okay."
We took it.
So it says circles on it though.
This one, right?
Does it say? Is that a first one? A circle?
Yeah.
Yep. There we go. All right. It says, suppose RST is inscribed in a circle. Okay. Inscribed. What does inscribed mean? On the inside, right? Okay, so inscribed. So I'm going to go through and I'm going to draw a circle.
On it.
Give me one.
And circle centers O.
Give me one.
And this is going to be R, S, T. Okay, so inscribed means that S is actually on the edge of my circle. Okay, if it was touching, if S was right here at the, that should be an O, sorry. If S was right here at this point right here, this would be a central angle, but this is inscribed. So this is going to be X right here. That's X degrees. Now, this is the angle, right? Say yes.
Yes.
Okay, so what do we know about the arc?
That it's 2 times the inner angle.
Excellent, good job. It is 2 times the angle. I'm trying to get my colored pencils here for this. I'm trying to make it all fit. Huh? We did a couple of them like this yesterday. So this, which is my crust, on the outside over here, it's supposed to be 2 times this angle. And I know, hey, I didn't move back there for you to conversate. So I know that this would be 2 times whatever this is. So this is going to be a 2x degrees. Right? Okay, even though it's just 2 times whatever that is. Okay, describe the measure associated with this. So, if RST is an acute angle, describe the measure of its associated central angle, ROT. So that would be R to O to T. So what is ROT going to be then? It's the same as the arc, right? Very good. Same as the arc. So my arc is 2x. So my central angle is? Thank you. Okay, so the next one says, right here. So for this one it says if RST is an obtuse angle. What does obtuse mean? More than 90. More than 90. Obtuse means more than 90. Describe. Okay, so I'm going to do another circle for this one. So I'm going to do this just so we can see what this would be. So this is my circle O. And that's going to be the diameter right here, okay? So now, if it's going to be more than 90, that means I'm going to have a point somewhere over here. It's going to connect over here. and it's going to connect over here somewhere.
That's obtuse.
Yes, this is obtuse. So now, isn't this the diameter? Say yes.
Yeah.
Wait, the diameter is half a circle, isn't it?
Yes.
So half a circle is how much?
180.
Very good. That's 180. So if that is 180 right there, if these were to connect right there, I know my angle is half of my arc. So if the arc was 180, this would be 90.
Yeah.
But since this one is more than, so it's touching over here and over here, so we're saying that this is my RST. So it's asking measure of, describe an obtuse angle, describe the measure of its associated central angle ROT. Now R to O to T. What happened? Is it still going to be so it's no longer going to be the same as the arc, is it? Okay, because the arc, so from here to here is 180, isn't it? And this is more than 180. Say that's 20, and say that's 20 also. So all this together would be how much? That would be 220, right? That would be 220. So now this one right here, is that going to be the same now?
Yeah.
Say no. No, because my angle is measured from the inside. It's a smaller piece. You don't measure angles more than 180. Because an angle is a straight line. Okay? It goes to a straight line and that's it. So if it were to start going back down this way, instead I would measure it this way. Instead of trying to measure it that way. Does that make sense? So my angle is only going to go up to 180, but not more. Otherwise you measure it from the other way. Yes?
Wouldn't the two sides be 10 because the arc is 20? And then the rest?
No, because if the arc is 20, it would need a line going here, so it'd have to connect somewhere on the edge over here. But because this one is not actually continuing, it's not going to be there. So if this went all the way over here and they both connected at some point on the edge, then it would be. Does that make sense? Okay. So because of that, we know that the central angle is not always the same as the arc. So I'm going to write this out. When it is greater than, there's a greater than symbol, 180 degrees.
What?
Say what?
What is that saying?
It says the central angle is not the same as the arc. Remember on this one, the central angle is the same as the arc? But that's not true if the arc is more than 180. Because we can't measure it this way. We're not going to measure this way here. We measure the smaller side. Yeah.
So how would you describe A?
How would I describe what?
A.
A? Like on this one here?
Yeah.
Okay, this one is an inscribed angle. It's touching the edge of the circle.
No, I mean like how we wrote down something for B. What would we have written down for A?
Oh, I'm sorry. Right here, we would say it's 2x. I wrote it on this one right here.
Oh.
So it says angle ROT equals 2x degrees. I'm sorry, I wrote it on that one. Thank you. All right, so let's continue. So let's take a look at number 8. Number 8, it says, consider the inscribed triangle shown here. Now, The measure of an arc is equal to the measure of the corresponding central angle. Write an equation for the measure of arc AB. Okay, so I'm going to arc AB. You guys don't have to do this. I'm adding color for all my YouTube viewers because they commented and say, hey, do more diagrams.
I'm pretty sure 2 people are not in here.
Hey, if you're looking at my comments, one person says this guy needs a raise. And he says that every day.
Commenting on your own stuff.
Anyway, alright, yes.
Can I go to the restroom?
Yeah, go ahead. Alright, so let's take a look. It says write an equal. Can you please stop?
I apologize.
Now, if AC is the diameter, so the right here is going to be a semicircle, right? So this is 180, isn't it?
What?
From A to C,
It's 180.
it's 180. So I'm going to write 180 right there. So, this is my inscribed angle. If my endpoints are A and C, the arc is 180. What does angle B? 90. Because it's going to be half of the arc, isn't it? So this one right here is going to be 90 because it is half the arc. So now that I have that there, I know that because of this, if I want to write an equation for angle, measure angle A or arc AB in terms of measure of BC, so let's say that measure of AB is equal to, now, how would I figure it out? How would I figure out? I know that this whole side is 180, right?
Yes.
So this side over here has to be 180, right?
Yes.
But how would I figure out? So if I knew what BC was, what would I do to figure out AB? Subtract it from?
180.
So even though I don't know what it is, could I still just say I'm doing it?
Yeah.
So I could say it's going to be 180 minus measure of arc BC. So that's what it means by writing it in terms of the other.
That's it?
Yeah. Now that I have that, I have some other information to add to my graph. It says triangle ABC, that's the big one, triangle ABC. Use triangle ABC, write an equation for measure of angle ACB, in terms of measure of angle BAC, and explain. Now, this is a right triangle, isn't it?
Yes.
That's why I had us identify that being a right. So the other two angles in a right triangle add up to what?
90?
90. Very good. It is 90. Because if I take 180, right, the whole thing, subtract 90, what do you get? 90. So that these two together have to add up to 90. So to write one in terms of the other, I'm going to say measure of angle BAC is equal to 90 minus measure angle ACB. Alright, so now that we have that information, I also have some information here. It says BAC is 27 degrees. So let's look. BAC is 27 degrees right here. Find measure of angle ACB. ACB. So I know that these two together, ACB and CAB together have to add up to 90, right? So what would I do to figure out C here? Subtract it, right? Let's go ahead and subtract it. What do we get? measure angle ACB is equal to how much? 63 degrees. And it says arc AB. So let's take a look. Arc AB is right here in green. So A is inscribed, right? So arc AB is right here in orange, right? So BC is in green. So if I put my 63 right here, so what can I say is going to be the arc of AB? No, that's going to be BC.
Oh.
I want AB. 126? Yep.
Yeah.
Yeah. It's going to be 2 times that inscribed angle. So I'm going to have 126 for my angle, or my arc, I'm sorry, and measure AB is 126 degrees. Yeah. Too fast?
Yeah.
Okay.
Wait, oh, okay.
Alright, so, okay, I gotta move over. Alright, so for right here, in the diagram below, C is a semicircle. C is a circumcenter, I'm sorry, circumcenter. Circumcenter of triangle X, Y, Z. X, Y, Z. So it's actually going to be the center right here. Classify each statement below. So because of this, now I want you guys to see this carefully. Is this the radius from C to Z?
Yeah.
That's the radius, isn't it?
Yeah.
So what do we know about CZ?
It's radius.
It's the radius. What about CY?
It's also radius.
So what do I know about those two radius?
That they're equal.
They're equal, right? What about CX?
That's also a radius, so they're equal.
That's also going to be a radius, so that's also going to be, yep. Okay. And because of that, if this right here is going to go through the center, if this is going through the center right here, this is 180 over here, right? So what is Z going to be? 90, because this is the angle. The angle is half of the arc. So my angle here is going to be 90. So I'm just filling up a whole bunch of information here so we can go through and start doing this. So let's ask, is CX congruent to CY?
Yes.
Okay. Is CZ congruent to XY?
No.
Nope, because XY is going to be twice that, right? Okay. Is triangle CXZ, CXZ, so that's going to be over here, isosceles.
Yes.
Isosceles has 2 congruent sides, right?
Yeah.
There we go, right there we have that. Triangle CYZ, CYZ, so that's going to be this little one here, is equilateral.
No. Wouldn't it be isosceles?
Yes.
This one, because of this, we didn't actually go over this property in these triangles, because it kind of, I don't know, it wasn't in the curriculum, but it used to be. Anyway, because that this is the circumcenter of this is 2 times the radius. This is also the radius from here to here. But if I'm looking at it, this should be just 1 of the radius here. So this is going to be the radius also. So it's going to be the same. And then when we get, so this is 1 radius, this is 2 radius, and that means this one over here is going to be it is going to be whatever the radius is. I'm going to say r times rad 3. But we did not cover that this year. It was not in our curriculum, but I'm just going over it. It's just information to know. So that's the reason why that this one is going to be an equilateral triangle. So we're going to say yes on that one. No, it's not. This is just something, I'm trying to go over everything that you could have. So it's things that we should have gone over, but it wasn't part of it this year. All right, XY is the diameter of circle C. Yes, it is. There we go. All right, let's take a look at the next one. Select correct answers. Which of the following best describes how to find the circumcenter of a triangle? Okay, so we did not cover this one. If you're constructing an inscribed circle for a triangle, choose the best fit. So, because of this inscribed circle, so we also did not cover this. We did not put a circle inside a triangle. We put a triangle inside a circle, but we never put a circle inside a triangle. So this is another one that we did not cover. So you guys can put a little X right there if you need to. Okay. And you can do the same thing for this one because we did not cover that one also.
Number 4,
2 and 3. All right. So this one you should know. What shape is inside here?
Equilateral. Quadrilateral.
Quadrilateral. It's a quadrilateral, right? So, and what type of quadrilateral is this? Nope. Is it touching all edges of the circle? Is it touching all edges? Inscribed. It is going to be inscribed. So if it's inscribed, I have other properties I could use because of that. So because of that, I know that use diagram and explain why. Measure of angle ADC is going to equal 85 degrees. So, in an inscribed, what do we know about this and this? They're going to be supplementary, right? So, I know that angle D plus angle B has to equal 180 because opposite angles in an inscribed quadrilateral is going to be supplementary. So this one is going to be 85 if you want to add it up to see what it comes out to be. So angle D plus angle B equals 180. They're supplementary. Alright, here's another quadrilateral. Tell what you can conclude about measure of angle R, measure of angle Q, and measure angle S. So, first, what's going to be angle R?
130.
130 because those two together have to add up to 180, right? Okay, so I'm going to say that is angle R equals 130 degrees. Okay, so that's 130. All right, what else do I know? It could be.
QS is 100.
Okay, so what is?
QS.
So Q to S, from Q all the way to S is 200. Oh no, I'm sorry, 100. Why did I get 200? Sorry. 100, right? And from Q to S is going to be, so the major arc QTS is what?
260.
260, very good. So, because of that, okay, I know that these ones right here. I'm gonna take a guess at this one, but because there is no information saying the size of Q and S, I can't actually do much. Because if I actually take a guess and say, oh, that's half, that's 50, I can't do that. That wouldn't work out. So I have to just go with that I know these two, and then I know that S and Q together have to add up to 180.
So it's 90,
No.
right?
Mm-mm.
Because of the both,
I can't say that they're both the same.
oh,
Because if I look at this one from Q to R to S is 100, right? And then the other side, Q to T to S is 260. So I can't say, so if I knew one of these over here, I could actually say something else about this. But because of that, so Q and S together are going to be supplementary. I can't solve for those. There's not enough information to solve for those. So angle Q plus angle S equals 180, and I don't have any more information to solve. All right, this next one, we didn't do these constructions. We did not do these constructions, so it basically construct the circumcenter of the triangle. So we would basically divide each one in two, and then we would actually connect those to see where the center of the circle is. So that's a no. Construct the circle inscribed in the triangle, so that would be putting a circle inside there. So we didn't do that one. We didn't do that part of construction. Alright, so quadrilateral is inscribed in circle O. That's important. A and C are supplementary. So since we know A and C are going to be supplementary, I'm going to have, and B and D are also supplementary. So arc BCD, B to C to D, and DAB, DAB make a complete circle so that both of them together equal what?
360.
360. Angle A is an inscribed angle, and its intercepted arc is BCD. So we have BCD. Angle C is an inscribed angle, and it's intercepted with arc DAB. DAB. So that's the other side. DAB here. Right angle measure of angle A and measure angle C in terms of the arcs. I know that angle A is equal to, angle A here is going to equal what? No. Think about it theoretically. If I said make a formula, you would say the angle is what? No, don't give me a number. What do I always say? I said the angle is?
The zero thing.
Nope. The angle, the inscribed angle is blank, the arc. Thank you. So, inscribed angle is half the arc. So, measure of angle A is going to be 1/2 of what arc?
C, I mean,
It's going to be over here, right? BD? Or DCB? So, DCB means same thing. Alright, do the same thing for C. How would I say C? Angle C is equal to? Say the whole thing. Half of So DAB, yes. Write an expression for these two right here. So, since I know both these together, because I've already stated that they add up to 360, right? So I had that first. So now I'm going to say that 1/2 DCB is plus, 1/2 DAB was equal to, now, it's not going to be equal to 360, right? Because these two together would add up to what?
180.
180. So half of the arc here plus half the arc here should be half of the 360, which is 180. So I have this right here. So half the two arcs together have to come up to be 180. Show why expressions in part C equals 180. Because whatever we have, right here, okay, it's always half of my arc. The whole arc is 360. Oh, I'm sorry, you guys can't see this. There you go. Yeah.
You said when the angle is greater than 90, that it's not always half the arc.
No, that was a central angle. If it's inscribed in the middle, that's a central angle. So right here, central angle is the one on the center of the circle. But we're talking about inscribed, the one on the edge. Alright, so the whole arc is 360. And using the formula, it's always going to be half the arc. The angle will always be half the arc. So, half of the arc is going to give me 180. So, A and C are supplementary. A similar argument shows that B and D are also supplementary. Alright. Now, this one right here. So, if you guys have your handy dandy notebook with your formulas on it, please take that out, write me out. No clue where mine is anymore. So many people borrowed my notebook that I can't even remember where it went. Let me see if I can see. Stealing yours. Alright. So, I'm stealing hers. We have this thing right here. Sector. We have r theta. And formula area is area of a sector. Now, I want you guys to pay close attention to something right here. Right here. See this right here? That's degrees, right? Say yes. Yeah, because it says degrees. Now, there's another way of measuring angles, and it's called radian. Okay, we never got to this portion in the course, but when we do radian, it's slightly different. The area of radian is going to be equal to 1/2 r squared theta.
Is that say pad or rad?
Rad. Okay, so you guys are writing this in your notebook, and I just wrote in hers.
Another question.
I have an answer.
Does that say arc A or
That
area?
said area.
Area. Sorry. Trying to make sure I do not give you the wrong one. I have it on my reference sheet somewhere. I just can't. Oh, there it is. Because the radian one is slightly different. That's. There it is. 1/2 r squared theta. There it is. Okay, so you guys have all that written down, right?
Mm-hmm.
And so, especially for people trying to sleep. I know. Where's the monkey? Oh, dang it. Okay. All right. So, now, this one right here is going to be whatever my angle is. It's going to be whatever my angle is, right? Say yes. So, that's going to replace the theta. So, my area would be, area is equal to, this is in radians, 1/2. What's my r?
10.
So it's 10 squared, and theta is m. Okay, so this is going to be in radian. Now, let's do it again in degrees. Because you're going to have to see both. On the final exam, you're going to have both. Yeah, because you're going to have to know radians and degrees. Yes. But I'm giving you a reference for this instead of just yelling out you're failing. Yes.
So, if we do this on a calculator, are we supposed to switch the mode to radian?
No. The only time you switch, everything's degrees. The only time that you're going to have to switch to radian is when you go to trigonometry or pre-calculus and you're working with sine, cosine, and tangent, and you enter those in the calculator using a radian method. Okay, so if this was degrees, it would be area equals, remember it's pi r squared theta, right? Okay, but it's theta over 360, but in this case, m over 360, right? Okay, r, which is?
10.
And pi, right? Pi squared. So now we have it in both ways. Okay, I just wanted you guys to actually be able to know how to do this one because it is going to come up. All right, so now 10 squared is 100. 36 over 100 is?
36.
It's going to be 100 pi over 360. I have to reduce it. Is it that time? Yeah. So let me finish this problem. All right, so if I reduce my fraction by 10, it goes 10 over 36. I can reduce it by at least 2 more. So it's 5 pi over 18. And there is an m there too. Sorry. All right, like, share, and subscribe.